Mercury, the scorched planet Mercury, the smallest planet in our solar system, may be the closest to the Sun, but don't let that fool you into thinking it's hot all the time. Sure, during the day, temperatures can soar to a blistering 430 degrees Celsius, but come nighttime, it's a whole different story. The temperatures can plummet to a bone-chilling -180 degrees Celsius. This stark contrast happens because Mercury has almost no atmosphere to regulate temperatures. Instead, it has a very thin exosphere, incapable of holding onto heat. As a result, the surface experiences extreme swings in temperature. Now, while the temperature may grab your attention, it's not the only thing you need to worry about. Mercury doesn't have a breathable atmosphere, and that's a major issue for any would-be astronaut. In fact, Mercury receives nearly 7 times the solar irradiance that Earth does. It's like standing in the center of a cosmic furnace. The lack of atmosphere means that solar radiation bombards the planet directly, and without any air to shield you, that radiation would quickly become lethal. Add to that the planet's rocky surface, full of craters, cliffs, and jagged terrain, and you've got a landing zone from hell. Plus, the minimal air resistance means slowing a spacecraft down would be incredibly difficult, leading to a much higher risk of a high-speed crash landing. But wait, there's more. Mercury's slow rotation means its day lasts nearly half a year. That's right, a full day on Mercury equals around 176 Earth days. You'd be baking under the intense heat for ages before the cold of night sets in. Even with the best spacesuit, NASA's current tech can only withstand temperatures up to 121 degrees Celsius, nowhere near Mercury's searing daytime temperatures of 430 degrees Celsius. And as for the nighttime freeze? NASA suits can only handle temperatures as low as -157 degrees Celsius, below freezing, so at -180 degrees Celsius, you'd be in a race against time before your suit fails. Your best bet would be to try to land in the Terminator zone, the narrow band between the day and night sides. In this region, temperatures are more moderate, though they can shift quickly. The risks remain high, but it's the only place where survival might be possible, even if it's just for a short while. Venus, the hellish twin. Next, let's talk about Venus, the closest planet to Earth at just 40 million kilometers away. That means the journey would only take about 4 months in a spacecraft. Despite its proximity, Venus is anything but hospitable. For starters, Venus' gravity and size are similar to Earth's, which might initially feel familiar, but don't get comfortable just yet. The first warning sign comes from Venus' yellow clouds, which look beautiful from afar, but up close? They're made of sulfuric acid, which is incredibly corrosive and would destroy your lungs in seconds. Now, let's say you have a spacesuit advanced enough to filter out the acid. That's just the beginning. As you descend into the thick atmosphere, visibility drops drastically. The air is made up mostly of carbon dioxide, and only a tiny fraction of the sun's light makes it through, leaving the surface in a perpetual gloom. And the heat? It's an unforgiving 450 degrees Celsius, way beyond anything Earth-based technology can withstand for long. As if that weren't enough, you're also dealing with atmospheric pressure that's roughly 92 times that of Earth's at sea level. In short, you'd be squashed under an immense weight of toxic gas. Even if you somehow make it past the oppressive heat and pressure, your biggest concern would be the violent winds, gusting at up to 300 kilometers per hour. These would make movement nearly impossible, as you'd feel as though you're trying to wade through a heavy liquid. The dense atmosphere, heavy with carbon dioxide, would make even simple actions feel like an enormous struggle. Without a pressurized suit that could withstand the crushing atmosphere and the sulfuric acid, you wouldn't last long. Mars, the red desert Mars, Earth's neighbor, is often hailed as the most habitable of all the planets in our solar system. It's the second closest planet to Earth, and it has been the focus of many space exploration missions. Temperatures on Mars are far more bearable than those on Mercury or Venus, with a daytime average of 20 degrees Celsius, which could feel downright comfortable. However, things take a turn as night falls, or if you venture towards the poles. Temperatures can drop as low as -125 degrees Celsius, making any hope of survival a test of endurance and preparation. Mars, like Mercury, suffers from an incredibly thin atmosphere. It's made almost entirely of carbon dioxide, with trace amounts of oxygen, meaning there's no breathable air. Add to that the fact that the atmospheric pressure on Mars is less than 1% of Earth's, and you've got a real problem. Without the aid of life support systems, you wouldn't be able to breathe. Even worse, Mars' surface is exposed to high levels of radiation due to the lack of a protective magnetic field or thick atmosphere. The average radiation levels on Mars are 40 to 50 times higher than on Earth, which means prolonged exposure could lead to serious health issues, including cancer. To survive on Mars, astronauts would need a habitat that's airtight and well insulated, along with a sustainable life support system. Mars is also known for its violent dust storms, which can last for months at a time and can engulf the entire planet. Winds can reach speeds of up to 100 kilometers per hour, and these storms could wipe out solar panels, damage equipment, and pose severe hazards to any humans trying to survive on the surface. Jupiter, the giant of the solar system. Jupiter, the largest planet in our solar system, is known for its sheer size and the intensity of its storms. While it's impossible to land on Jupiter due to its gas giant status, it doesn't have a solid surface. Let's imagine for a moment that you could somehow make it through its violent atmosphere. Jupiter's extreme radiation levels would be your first challenge, with radiation so intense that even 300,000 kilometers, 186,411 miles, away, it could easily penetrate any conventional suit and make you a very short-lived astronaut. But let's say you've got a hypothetical suit that can withstand this radiation, what next? Jupiter's gravity is 2.4 times stronger than Earth's, so you'd be falling fast as you enter the planet's upper layers. These clouds are composed of frozen ammonia crystals, and temperatures are a bone-chilling -150 degrees Celsius. Winds whip around at speeds of up to 482 kilometers per hour, which would make maneuvering impossible. If you somehow managed to descend about 150 kilometers into Jupiter's atmosphere, you'd reach the farthest point ever explored by NASA's Galileo probe in 1995. Beyond this point, things only get worse. The pressure and temperature both increase dramatically, and the further you descend, the stranger things get. After hours of falling, you'd eventually encounter a substance known as a supercritical fluid, an odd state that is neither gas nor liquid but somewhere in between. If you manage to push further, you'd find yourself in the realm of metallic hydrogen, a dense liquid that traps everything in its path. And if you somehow survive that, you'd reach Jupiter's core, where temperatures reach a scorching 24,000 degrees Celsius, over 4 times hotter than the surface of the Sun. Here, pressure is an unimaginable 100 million times that of Earth's. Saturn, rings and hurricane. Saturn, the second largest planet in our solar system, is another gas giant with an incredibly hostile environment. First, you'd need to avoid crashing into one of its 146 moons. Once you make it past that, you'd be faced with Saturn's iconic rings, made up of ice, rocks, and debris from long-dead moons. Assuming you're a skilled pilot, or your spacecraft is indestructible, you'd still have to contend with insane winds of up to 1,800 kilometers per hour near the equator. At Saturn's North Pole, you'd find a storm large enough to fit 2 Earths inside. This massive storm features ammonia clouds, and temperatures there can drop to a frigid -250 degrees Celsius. As you descend, the temperatures would start to rise, but the pressure would become your greatest enemy. By the time you reach deeper into the planet's layers, you'd be encountering liquid gases that would make survival impossible. At Saturn's core, temperatures reach a blistering 11,700 degrees Celsius, and the pressure is 1,000 times greater than what we experience on Earth. Uranus and Neptune, ice giants in the void. Uranus, the ice giant that spins on its side, and Neptune, its twin, are 2 of the farthest planets from the Sun. The temperatures here are some of the coldest in the solar system. Uranus, in particular, is so cold that it's considered the coldest planet in the solar system, with temperatures dropping as low as -224 degrees Celsius. Both planets have atmospheres full of methane, which gives them their blue color, but the gas is toxic, and the pressure at the core would crush anything that ventured too deep. On both Uranus and Neptune, the winds reach supersonic speeds, and the extreme cold would freeze you solid in minutes. But beyond the frigid temperatures, there's a strange phenomenon, diamond rain. As high pressure breaks down methane, it forms diamonds that rain down from the skies. But even this rare spectacle comes with a deadly catch. The pressure on both planets is about 100 times greater than Earth's, and it would be enough to crush any spacesuit or body that dared to venture too far. Conclusion: the dangers of interplanetary travel. While the idea of traveling to other planets is an exciting and awe-inspiring one, the reality is that the conditions on these planets would make survival nearly impossible. From the scorching heat of Mercury and Venus to the extreme pressures and cold of the ice giants, each planet offers its own set of deadly challenges. The best we can do for now is study them from afar, waiting for the technology that might one day allow us to explore these alien worlds without ending up as stardust.